So hello, I'm Kris. I'm working for QuantLab, which is high-frequency trading company where we apply a lot of templates, and that's why we will be talking about that here. So welcome to nfpack element, a case study where we will be looking at different approaches towards getting nth element of the variadic pack. We'll compare them and we'll see which one is the best, and maybe we'll see the future as well. Potentially we'll see. If anyone thought that would be nth element, std nth element, generic programming, sorry, not that talk. Nth pack element, way more exciting. Okay, so hopefully that will be nice for everyone. So without further ado, let's begin. So what we'll be talking about, why we actually need nth pack element, why we can do easily first and last. That's quite easy in C++. But the nth is actually way more difficult, and there are tons of ways of doing that. And this presentation is based on a lot of people's work, Daisy's work, as well as Lois Dion work, and a lot of people who I'm not mentioning here. But obviously Sean, who will be here in a moment, the circle, that will be also mentioned, because we will be, in the end, the goal is of this talk to verify how far are we actually with C++ in comparison. So all of that we'll be doing in order to apply that for the get on the tuple, because obviously we have to have that in order to get nth element. The main goal, the main purpose, the main high point of this talk will be the benchmarks, where we'll compare all the solutions we apply here, which compiles with different compilers, and we'll see where we're at with that, and we'll sum up. So hopefully that makes sense, and you're excited as I am about that. Ooh. For the audience, yeah. Great audience, for the record. So if you have dark blue background, there'll be something I think it's important to remember, especially regarding some of the solutions. Everything is powered by Compiler Explorer. Thank you, Matt. All the Godbolt links I provided, so including Circle as well. So the motivation. The simplest motivation is the fact that when we have a tuple with elements which have in the same type, we can't get it easily, right? It's like getInt doesn't mean doesn't tell us the first one, second, or the third one. But if we get the get0, we can easily disambiguate that. So that's the base motivation, and obviously there's a lot of TMP involved in companies like high-frequency trading is using a lot of TMP in order to get type lists or tuples into often different spaces, and getting nth element is really important part of the compilation times. Because the benchmarks, just for the record, won't be about runtime, because runtime is not existing in that case. So how we can get first pack element? So obviously, in my opinion, that's quite easy. Any ideas? Yeah, look.
It's taken the first arg, and then the next is template variadic args.
Yeah. So look, mention here that we can take the lambda, get the first, and rest, just ignore, return the first, and we're done. So for the first one, it's easy, I believe. There's also a really nice proposal about structure bindings can introduce a pack. Anyone seen that one? I'm really excited about it, because for this one, we can actually do that, and we can do way more. But that's the first example. We have a tuple, and we can destructure into the first and TSS. We have to have the name there. But yeah, we can get the first. We can also, we'll see in the further examples, a magic trick with make integer sequence and structure bindings, which is, I think, really powerful. So what about the last element? In my opinion, also possible and quite simple, but not really straightforward.
First, last?
First and last? Yeah, recursive solution, we'll take a look into that. But there's actually, for the last, there's a trick which you can apply. When you have an expression, 1, 2, 3, the value of it will be the third one, right there, the last one. So if we apply the fold over that, we can do that. So comma args, or args comma, dot, dot, dot. That will give us the last element. Also, it will give us a warning, unused value. But for now, you cannot cast to void that easily, because where do you cast to void? Because you need to return that element. But for that, you can do that, for example, and a lot of compilers will say, OK, you can do that.
You need also to ensure that there are no overloaded comma operators.
That's a valid point. The comment here is that comma operators, overloaded comma operators will screw up everything.
But
True.
This would actually invoke a assignment operator at runtime.
Now, if market at cons expert will verify that it's at compile time only, that's what we care about. But potentially at runtime if you have that over runtime Variadic pack. True, but at least it doesn't give us a warning. So last element of this proposal is actually really nice because we can do ... ts and last. Like, who would like that? Like that's super exciting, right? So we have a tuple and we get the last element out of it as easily as that. And we can do more because there's one more proposal from Quarantine, I think. Then actually there's not a proposal yet, just an idea that we could do the same with lambdas functions. So we expand all the elements front and then take the last. That'd be nice as well. Probably we'll have a lot of issues with overloading, other ones, greediness. But what about the first and last? So if you want to combine those two, we can do it in we combine both solutions. We get the lambda, we get the first, and the last, we do the ... We can do that. But what is super exciting, why I'm showing it, is that with this proposal, we can actually get the first ... ts and the last. So that's pretty cool. It's really nice to have this ability.
What if there's only one element?
That's a great question. What is when it's one element? It crashes at the moment. So I don't know exactly, because it crashes for 1 and 2 elements as well, because then it doesn't know that the TS should be empty. So I'm not an author of the proposal, so I'm not sure what is supposed to happen. I would assume that if you have first only, it shouldn't compile. If you have 2, the TSS should be empty. But it's a great question. At the moment, as it stands, it's just IC. But you can do it when you have 3, which I'm showing here.
Well, the last one, the middle one should work today without any proposals, right?
The middle one.
No, because then you have an empty expression with no initializer.
Right, so it won't compile.
You need an initializer to the comma.
Yeah, so it won't compile.
Yeah,
But
Your laptop went to sleep. No, the projector.
Watch your step. Oh no.
Unsafe seat.
Where
Here
is
we
it?
go again.
This is an unsafe seat, yeah.
Okay. Where?
What'd you do, Fader?
We just knock the power out. It's okay.
We've done this before.
It'll just take a second for that.
All right.
Get it turned back on.
What did I do?
You just actually probably just got knocked out, so it's a little bit. It's okay.
Move out.
So at the moment, we're doing the recursive version.
You know my daughter's favorite joke?
Yeah.
Why did the cookie go to the doctor? Because it was feeling crummy. Wow.
Do you want to repeat that for the for the YouTube audience?
That was a good one.
You gotta hit the on button on the projector, it's on the top.
Takes
It takes a minute,
It takes a while.
I like your comma trick. I actually never thought of that before.
Are the commas on the, or are the dots on the wrong side in the,
Our light is on, but the
No, no,
line
no,
is
it's
off.
on.
That's okay, yeah. It just takes a long time. I still have the feed on my end, so.
It's booting up Linux.
You could put the dots on either side, right?
Yeah, right. You can put the dots on either side.
One side and on the other and the other side.
Yeah.
OK, we're back. Thank you. Thank you, Feder, for that. That was a nice break. So yeah, moving back to the first and last. Awesome. Otherwise, it will ICE. So the motivation for this talk, obviously, is to get the nth, which is not that easy. Because how we can do that? There are tons of ways of doing that. In my opinion, there's one proper way of doing that, but we don't have one at the moment. So yeah. And in order to get the nth element, why we want that? Because we want to apply that to the tuple. So when we compare the benchmarks, one of the benchmarks would be related to getting an nth element of the get using the tuple. So when you have the get, that's the goal of this talk. We will explore different solutions of the nth pack element applying the tuple, and we'll see which one compiles the fastest, which ones no-go, and which ones are maybe the future. So okay, are there any questions to the intro? Sounds good? Yeah, there are questions.
So it looks like we have, and please correct me if I'm wrong, it looks like there's like built-in language features like of very like parameter packs that you can get the first and the last. Like it's just like, that's how they decompose.
Right.
Why don't they decompose? Like why is it easy for them to decompose in that way, but not like more granular? Like so why can't you get the nth element? Like why didn't we just make that a feature of parameter packs?
Oh, great question. Why like we will get there actually. Like spoil the talk. Sorry. So the question is why the getting nth element is not a language feature? There's a comment.
Oh no, you go ahead. Finish answering first.
And I think we'll get there eventually.
Okay.
I mean, the point is not that you can get the first element specifically. You can get the first element or the second element or the third element or any finite number very easily just by writing out the matching. It's just that matching a partial pack on the left and partial pack on the right was deemed to be too hard. But I think he's probably going to talk about that.
Yeah, we'll try to get it. That's the talk. So yeah. That's the idea of the nth pack element, just return an element at the end position from the variadic pack. So in order to verify all the solutions, we'll look at some requirements. If you get the 0, we get the first element, 1, blah, blah, blah. And also, because one solution won't be applicable to different types, so we will add these requirements as well. And we obviously would like to compile for the element which is not there. Preferably, we would have a concept check or something like that, but we'll see. So that's the goals. Flexibility, we would like to support different types with that. Readability, but it's easy to follow. We will see a lot of template magic, sorry. So yeah, there'll be a lot of dark one. And performance, is there an overhead? So I can immediately answer that one. There is no overhead at runtime, but there is a compilation times which are involved. And we're talking here about scale, right? It's like thousands of elements or hundreds of elements, but applied many, many times. So solutions, ideas. Usually the ideas are, I put them in the 3 buckets. One is to do some magic with the function so that we get the nth element before, then we get the nth, and then the rest. So the magic is something which we'll explore here. There are a lot of ways of doing that. The other magic which we can also apply is like create a struct. We have an ID, type an ID, and then kind of cast it back to one of these elements based on the nth which is applied for the nth pack element. I hope that makes sense. And the most desirable, it's maybe language feature or extension. There are some extensions which are in Clang. There are some compilers as well. So which solutions we'll take a look into? So std array, that's simple because that works for the same types. We'll start from there. Recursion, just to point out that we don't want to do it. We'll actually apply it 2 different ways to see whether the overload is more expensive than if const expert inside. That might be surprising for some. Arg expansion, so that will be related to also the concept expansion which Daisy was talking about at the talk, at CppCon. We'll look into Boost, MP11, the abilities to help us. Preprocessor, of course, we have to try it as well. That was the hardest. I was like, C++ when it's hard to use C preprocessor anymore. Type element, that's something which Louis Dion added to Clang. It's great, however, it doesn't work for, and it only works for types. So we'll have to do a bit of magic to scale it. Oh yeah, and circle shown is here, so there'll be a lot of goodies about that. So std array. Any ideas how we can do it? That's quite simple, I think. We have a varadic pack. Static assert, doesn't matter. So we get the array, we put all the arguments from the varadic parks into that array and get the nth element, right? I would say, and you can quote me later on that, that's close to the perfect syntax. Just this array is not there, and we there. But maybe there is a solution which looks like that, I don't know.
Can you do the same with initializer list?
A question whether you can do that with the initializer list? I think so, yeah. No?
Square bracket on initializer list is not const expr.
No, not with a square bracket, but with a const expr loop. It was just a for from a loop iterating begin to. I mean, it's a const expr function. Then you can write a for loop inside.
The comment is you might experiment with the initializer list. What would be nice here if you could just remove the array, maybe that would be nice, but that wouldn't do what we actually want. So for the requirements of that solution, everything is passing besides the fact that it works only for the same types, right? So we cannot make an array with different types. So all in all, we won't consider that solution when we will be benchmarking because it's not really that flexible. So it's not flexible because it's constrained to only one type. I would say that's quite easy to read. It's not a lot of magic in comparison to what we'll see in a second. It's fast to compile as well. We'll see. We won't see that, but since it's a language feature, I would assume it's faster than others. So let's get overdone with that, since we have to. So recursive installation, the first one is with two multiple overloads. So when we have the requires here of n equals 0, meaning that we don't have, we get the first one. So we return an argument. Otherwise, when we have n greater than 0, we do that recursively until we'll, get out of here and here and here. Just get them out of the variadic pack until we'll get to 0, and then we'll take the arc. Make sense? So what is bad about that solution? We have two different overloads. I would say not ideal because we have to know about them. We have to sync them. And obviously, it's slow to compile because we have to instantiate that function all the time. But it satisfies all our requirements. So that's good. It works with different types. It's kind of readable. There is a bit of magic for the final case. If you screw that up, you can scrap your compiler because it will try to compile it forever. And not ideal when you have thousands of types or something like that. It obviously depends how much memory you have as well. And it's slow to compile, and we'll see that because it's a recursive solution. It has to go and instantiate that function all the time. So, yeah, there's a question, Ben.
How is the error message with that solution if you put in an n instead of bounds?
Great question. So Ben asked, what about the error message here if n is greater than the variadic pack?
Yeah,
Yeah, function not found, I guess.
As written, something about being unable to call something you have.
Yeah, I would assume that we'll get tons of try to call this one, this one, this one, this one, this one. Yeah.
Yeah, you can say just say requires in is less than size of ... args plus 1, and then you get the exact error message you want.
Right. Right. The point is here we can improve the error messaging here. There was a question there, or?
I just wanted to mention the same thing. It's trivial to static assert.
Yes. Yes. The comment is you can trivially static assert and make the error message better. Good point. So alternative solution would be to do the same, just with one function call. We don't have the overload. Any ideas? Is that faster to compile or slower to compile?
Ought to be faster.
No, that's
There's claims both ways. I like that. So we'll see. My bet was that it would be faster because we don't have overloads. But I don't know, actually. Okay, I know, but. So, OK, it satisfies all the requirements as expected. Works with different types, yes. Still a bit of magic because we have it if cons expert, but we don't have these overloads. So I claim here performance, but that was just my assumption. I wouldn't count on it. That assumption was at the point of time when I was making that slide, not when I made the benchmarks. So
you mean runtime performance because there's still no runtime.
Yeah, runtime overhead is not involved at all. Is it?
So feel free to put this answer off until later if you have more slides about it. Did you try Odin's approach to recursion, where you split out more elements than just the first one?
Great question. Did I try like trampoline or whatever it's called?
What is Odin's library called?
Right.
I forget.
Quasir, yeah, something.
Yeah.
I can't pronounce that. Yeah. Did I try Odin? I didn't. Sorry, Odin.
That was the one that was winning MetaBench last time I checked. It was actually the fastest.
Okay.
Is that just subdividing the parameter packs and everything? That's actually what I was trying to
So there's a comment, there's a solution which might be fastest, but I would claim it won't beat the fastest solution which is provided either way. Bold claim, but we'll see. So for the next solutions, we'll have to learn a trick which is like unrolling in place, which is often used in the examples which are followed. So we have the index sequence. We create it in like C++20. We can do it in the in-place lambda and then call expression. And the void of ISS is just to do the expansion, the fold expression. And that's what I was referring to this proposal. That's super exciting because you can do the same, exactly the same behavior with 2 lines of code. Make index sequence supposed to, it doesn't work at the moment, but it's supposed to, according to the proposal, to destructure into the ISS, and then you can do the same. So you don't have to do the lambda invocation at all. So if you do, unroll with 2, the assembly will unroll it into the code, the assembly directly. So that's pretty cool. So let's look into the arc expansion solution, which basically applies this thing, which is the lambda, immediately invoked lambda expression with the size of n. And then, yes, that's where a bit of magic starts. So we do this decal type of, like we pass the pointers in order to get this void star. We do the decal types of void star ns, and that's just to expand the elements. And we do that just in order to the fact that we pass the arcs.dat. So n will get here, then we'll get the one which we want, and then the rest doesn't matter. And we return the nth. So that's the way we can approach that. Are there any questions to that?
Is this using that new proposal to allow you to do the packs on either side, or
No.
Just the syntax is confusing?
So question is whether that's using a new proposal. No, it doesn't. This one is actually not expansion because we know those elements. So it's not like auto blah blah. It's like we know how many elements there will be. So these NSs here are really important.
Okay, I got you.
And the void star is really important as well because we have to match it to this pointer. So yeah, we can do that. Obviously, that's a library code. We don't want to see that probably in production. But it satisfies all the requirements. Work with different types. It's a bit of dark magic, I'd say. But there's no recursion, so probably it's faster to compile. That's the claim at this point. So we can do very similar approach, which actually was shown at CppCon. So in order to do so, we specify a concept which takes a type for the concept and an auto, which will be the number. It doesn't really matter. It's just true, expands, it's always satisfied. We do the same, meaning immediately invoke lambda. And the expansion here is like over the concept. So we have the prefix. The first type will be passed as a class. The is will be the second one. And we do ... meaning that we expand it n times here. That works in Clang and doesn't in GCC. Question?
I think what might at this point clear up the previous question is that those two ... mean different things.
Yeah.
One's a pack expansion, one's a pack deduction.
Yeah.
Which
Right.
one is which? This is an expansion.
Okay, there's more comments.
So the only thing that's changed here from the one immediately before is that we're using a concept instead of the cast to void pointer.
Yes.
Okay.
Yes, the only difference is this magic here. And there's also a comment that expansion and deduction of args are two different things as well, which applies here and in the previous example as well. So that works as expected. Works with different types. It's a bit of magic as well. You have to know about concepts a bit. Does it work with GCC? I don't know whether anyone tried to expand concepts. It just doesn't. And the claim is also that it's faster to compile. Are there any questions to this solution? No. I hope I'm not losing you yet, because we're going further. So, who likes MP11? Half the audience. So MP11 is a library which is improving compilation time, let's say, in Boost by a huge margin. If we compare that to, which we cannot pronounce, Quasir, it's very similar, I'd say. So it's really good replacement for, what was the
MPL.
MPL, yeah, thank you. MPL, yeah, I've forgotten about it already. Yeah, MPL, it's not the fastest to compile. If you can switch to MP11, just please do. So there are a lot of nice utilities in MP11, like Mplist, which is basically the type list. And we can do here, basically the solution is the same, meaning we'll try to expand TSS, get the arg, and get the author . And the way we do it is by getting the take the first n elements into the list, which will be propagated here through the lambda, and we expand that at the beginning. So this TSS will be the first n arguments from the variadic pack. That makes sense? So yeah, that's yet another solution to achieve the magic kind of the different way. So works with everything, no issues here. It's flexible. I would say that it's a bit better to read than the previous solution because we use some library features, so a lot of things are hidden. If you read the documentation and we know what mp-take does, it may be easier to follow. But not necessarily. It's still a bit of dark magic with this lambda, immediately invoke lambda. But yeah, that's where we are with C++. Okay, I know you were waiting for that, so let's do it. So yeah, it took me a while. So okay, and I did it for MSVC. It couldn't be asked with Professor Huda. So the idea here is that we can do the same as recursive solution, just in place basically. We just get all the overloads. So for I equals 0, I equals 1, I equals 0 will return the first, I equals 1 will ignore the first and return the second, blah blah blah. Okay. So easy. We have a function which calls the other function. And that's where the magic starts. So define, and yeah, so, okay, let's take a look. So we have this repeat, and obviously that only works to, I think, 256 elements.
No, it nowadays works up to 1024.
Okay, the comment Tobias mentioned that. So this boost pp limit repeat is 2024 these days. That's the comment.
Yeah.
Okay, so we can do 2024. Maybe if we compile it. But yeah, so the idea is here that we call repeat, which decrement the value so that we start from the previous one for some reason. When we call this npag element, that propagates some parameters to this macro. The first one, I think, it doesn't matter, so it's like not important. N and the type is something which we want. So n is the iteration, and the type is the one which we want, which is the author. And when we do the same in order to get the args on this pipe element, so that will do this arg1, arg2, arg3, blah, 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 and finally we will return the arg n. Any questions to that?
Why?
Question is why we would do that. Well, we do that.
That's a joke.
No. The question is valid. Why we would do that in production? Let's say. I've done that in order to see whether it actually compiles faster and the benchmarking and see how bad we can go with the solutions which we provide. But yeah, I wouldn't advise anyone to do that in the production these days for many reasons.
This actually generates 1024 overloads. Does the compiler actually compile 1024 overloads?
Yeah. We'll see. Sorry, we'll see the benchmarking. So it's not the fastest I can tell you that. But it works. So verify that on our requirements. Flexibility works with different types. Yeah, it's a preprocessor, so if you screwed up anything, good luck. Because it's a tag replacement, it took me a day to actually did it. So, and it has multiple overloads, so potentially it might be slow to compile, because you can imagine here that if you have a tuple like npag element for 3 elements, and boost pp limit is right now 1024, we still could do the 1024. So yeah, so in preprocessor, it doesn't really matter how many elements you have, it's how many elements you actually have to compile up front, which is probably not ideal. So any questions to preprocessor? Who would like to write that code? Oh, there's nice.
I just checked. Kpsir basically does that.
Uh,
It's the fastest.
Does that?
It recurses after 32 or 128 elements.
I see. Interesting. So the comment is that the previous solution, which we just discussed, is the fastest on.
If you recurse at a certain point.
Okay. If you recursive at a certain point. Right. Interesting.
It just peels off bigger chunks.
Yes.
Yeah.
Based on the size of the initial list, you peel off bigger and bigger chunks.
Right. Unfortunately, we don't have that solution here, so we'll see how it could compare maybe later. So another approach is, here we'll move to approaches which are a bit different, not necessarily doing this expansion of the args, more like creating a struct and trying to get one of the elements by either inheritance or something like that. So we still have this immediately invoke lambda, but notice here that we have something similar to what we have the concepts. We have class any, which takes the type and the number and just stores the value. So what we do here as the first thing would be to create a struct. And why we have to do that? In order to get the binding between the type and the index. Because otherwise we don't know how to access nth since we just have the types. So that's what is happening here on this line. So we get the arguments of the variadic pack. That will be the t. and then NSS, which will be the index, and then we just construct that struct. You can see here that the struct doesn't have to have a name as well, if that's an interest to someone. But then the trick is here that we return immediately invoke lambda with this struct, and notice here that we have an any of type t, which is deduced from the lambda, and n, which is passed from the argument of the nth Pag element. And due to the inheritance, one of them will be chosen. If not, we'll have an overload which doesn't satisfy that requirement, and we'll just bail out. And if we find one, we just return the value of it, and we're good.
I like this. This is awesome.
Yeah. So in your benchmark, it looks like for each n, you're going to get a new instantiation of this whole construct.
Right.
Okay. I'm wondering if the struct was pulled out, so the struct with the whole pack is instantiated once, what the performance difference would be.
Right. It's
No, they're different types.
Yeah, they're different. You're putting in different R. So like.
But here,
the template n, right? The n is a different template, so you're going to create a different.
But we can't have the args here. Look.
The args are the same, but n would be different.
Right.
So then, because that's different, then the whole thing would be.
Yeah.
Different.
Yeah. So the comment here is, could we memorize that part, and how that would impact the performance?
I think my tuple does that. Right? It does. I have like a struct that does this overload of the get.
We'll get to tuple. Yeah.
Yeah. So I'm interested to like to compare them.
Yeah. I have benchmarks for tuple. We'll see how bad or good is from stood tuple. Yeah. Questions?
Yeah, I think it's you or me.
I pointed like that.
Did you leave that an unnamed struct to make the rest of the code less ugly by comparison?
Did I? No.
Usually you don't see unnamed struct with like complicated.
Yeah.
It's just show off, you know. It's like so much magic happening here that is like that doesn't matter, and it fits on the slide. I don't know how to name it, by the way.
So the it's worse than different for every n, right? Because each invocation of this will be a different function template instantiation, which
Yeah.
means that each local class will have to have a different mangling, and the compiler can't figure out that it doesn't have to mangle this, so it has to generate every single one of them.
Yeah.
For every single time you call different args with different
Yeah.
n, it's going to be different.
It's n class by arg.
Right.
Yeah, so it's going to be, this is going to be very slow, I would guess.
I like that. Bold claim that it will be slow to compile. For the record, yes?
What's the underscore magic?
Just a name. Just a name.
Replace it by X.
Yeah, sorry.
Yeah, unnamed struct.
So the struct doesn't have the name, but the object of that anonymous struct has a name underscore, which we passed args, which are going to the, all like instantiation of this value. So yes?
If all t's are copyable, then it should also work with stud any, no?
Or student. Question is about the copyability of t's. Yes, that's a valid point. I didn't mention that. For the simplicity of this talk, all these value categories are not involved, whether something is copyable or whether we return a reference of that or not. I ignore that for the simplicity.
But the constructor of student is a const expert.
Stood any.
Generated one.
Like
Yeah, but it's, what it's really doing is it's a diverse step. It's inside there's a polymorphic going on.
well, stood any wouldn't help us much because it's not really a compile time expression.
Ah, okay, yeah, it's not compiled.
There's no retail.
It's not stood any. It's just
It's defined.
No, it's student and not in this way.
Yeah, stood any wouldn't help us because it's a totally runtime approach, right? Towards.
Any cast is not context for?
I don't think so, because you have to compare the type, ID, I think.
It's a dynamic address.
Yeah, moving on. Stood any at compile time probably wouldn't be ideal. Although it's like with all this proposal towards const expert virtual dispatch, maybe. I didn't verify though, so. So yeah, it works as expected. A bit of dark magic, not as much as the other solutions, I'd say, but still, if you don't see that often, the question about what is underscore, right? Because it's so, yeah, it's a totally valid question because it looks really weird. It's not natural code which we would write. Unless you work for high-frequency trading companies and you do TMP, that's our code. So yeah, no recursion. I would expect faster to compile. So as pointed out before, there's this clang only extension for type pack element added by Louis Dion at some point for like 3.10 or something. However, it only works with types. So the problem here is that we cannot take a type pack element from a tuple. That doesn't work like that. We can have type pack element from the TSS. So what we do here, we do the same. That's kind of boring. Always the immediately invoke lambda. And notice that with this proposal P1061 or whatever, that these two lines become one line, so it's a bit nicer. So we do the same, and then instead of getting inheritance from the lambdas, we can get one of element for this variadic pack. So any TRX NS, that's a variadic pack of types, and we get the nth. Nth will be one of those elements, and we just cast it because we know that it's there. And then we get the value of it. So it's similar to the previous solution, it's just a different way of approaching the nth type, which we have to cast from the struct because we need a value. So all of that would be very simple if we have just types. But because we have a values, we have to have the struct and cast it or do some other magic with this expansion. But yeah, that works. Any claim whether that's faster or slower than like it's compile intrinsic thing? So
It'd be pretty fast if you pulled out the struct. I'm skeptical that it would be fast to put it in there.
okay, but how would you do that without the struct?
You pull it out of the function.
Okay, I see. I see. So the comment here is that I screwed up and I didn't put it here.
No, outside of the entire thing.
Oh, but then you don't have the types, right?
The TRs is deduced.
So TRs we have to have, right?
You can pass it in. You can make the struct a template.
So why that would be faster if you have the template struct? We still have to instantiate it, right?
The difference is that you're separating out the instantiation of your struct with all the arg types versus instantiating the nth pack element.
I see. Yeah.
You might be right. I mean, I could be completely wrong.
Well, the flexible comment is that there are different solutions which could be faster. Not as fast as one of the solutions. So
Yeah,
I honestly don't care. No, no. I'm willing to explore other ones. I think that's a really good suggestion. Unfortunately, not explored in the talk. So that works. Works with different types. I would claim that because it is a Clang extension only, so readability of that requires you to know that it's not a standard feature, it's an extension. It obviously belongs in library code. And the problem with the type pack element is the fact that it only works with types, right? If we had something which would get us the nth element, we wouldn't have that talk, because that would be the solution. Or maybe not, because that would be only for Clang. So we would have a talk about different compilers. Why they do that? They don't do that. So okay, any questions to that one? There's a question in the back, Joe. So Joe asked whether GCC has equivalent. No, it doesn't. Unfortunately, it doesn't. For some of the solutions here are only for specific compilers, and I couldn't compare them. It would be nice to have, I guess, but maybe not, because I don't know how fast it is yet. So let's take a look into MPL 11, similar solution to what we had so far. We have the lambda And we can do kind of similar what we've done before. So who knows about MP inherit? A few people know. So MP inherit is a really nice utility where you pass types and it just do the colon TSS. It just basically inherits from them. Why we need that? Because we do the static cast. So we do MP inherit, then we take the element and nth position. So that will return any of specific type and index. And then we can cast that into the type which we want according to the element. So it's always, here is always the same case that we have to have the mapping from the type to an index, right? And we ask from an index to a type. Otherwise, that would be simple. But in that case, it's not. So we do the inherit. That creates basically the struct for us. And we do add. And we have to do add with inherit because it doesn't work with anonymous struct because it doesn't do it doesn't have TSS. So the struct is anonymous. So the MP11 doesn't work with that. Any questions to that? Ben?
Wouldn't this work with Mplist as well? It seems like your anonymous struct is kind of the MP inherit.
Yeah, that's a good point. Yeah, that actually would work with Mplist. So the comment from Ben is that MP inherit is not actually required here because we do add either way and then cast it to the anonymous struct. Oh, sorry about that. That's a valid point. Thanks.
So,
yeah.
MP at of MP list of the pack is just going to be any of targs and n, right?
Yeah.
So it seems like that part is entirely extra because you could just use n. You already have a symbol for it, right?
MP add only works on list types, so you need some type.
No. I mean, like the MP at and the MP inherit part is entirely extra because you can just use n. You don't need to.
But you don't have the targs. You have to get the type. Yeah, you have an n, but you don't have targs.
Oh, I'm sorry. Of course.
Yeah, that would be awesome. But yeah.
Of course.
So the idea is here we have a lot of types and indexes, but then we just have an index. So we have to go back to this specific type at this specific index.
Right.
And that's.
Sorry.
No worries.
So I think your anonymous struct here could be MP inherit.
Yes. Yes. That's I think what was intended. So the comment here is that instead of doing an NA, we could do MP inherit of that guy. Actually, we could do MP inherit here instead of this underscore altogether. But yeah, MP11 solutions are very similar in compile time to each other, so we won't gain that much here. So yeah, it works. Works with different types. I would claim that it's a bit better because we use some library features, so at least some part of the code might be understood by other developers. But then they go on to the other part. And MP11 is well optimized. As pointed out before here, it's one of the fastest to compile libraries if it comes to type space. Okay, and the moment we were all waiting for. So, can we do better? Can we do better?
Well, we have to see what it is first.
I like Crickle.
Yeah, it's not circle, it's Crickle.
Damn. We'll change that in the recording. Yeah. So circle. So do you remember the args, the array solution, where we have std array arg of n? What if we could do that? Yeah. Really nice solution. I think that's the expressiveness which you like. Like, how simple is that? It's like if you have that in the language, I don't think we need all those, trickery in order to get nth element of pack. There's like no point of me talking here when we have that. So yeah, thank you, Sean. And we'll see how it compares if it comes to the compilation times. So yeah, stay tuned for that one. That will blind you. Okay, so requirements. It actually works as well, so that's good. Yeah, I would say you can't express it better than that. Like I can't even imagine syntax would be nicer, but it's not C++. It's Circle. Maybe it will be C++. I wouldn't count on that though. But because it's a feature from the backend in the compiler, my claim would be that it will be fast to compile. But we shall see. So any questions to that's all the solutions which we will compare in the compilation times. Yes.
Does the circle syntax work for a pack of types as well as for a pack of arguments?
It works for all 6 kinds of template parameter packs.
Awesome, thanks.
So the comment here is that whether Circle is awesome. Yes. Ben.
My comment is that at this conference, this year's dark magic is next year's established pattern.
Okay, so the comment is we're waiting for the next conference. We'll see. Yeah. Okay, so we've done all this work in order to get the nth element of tuple. So yeah, by the way, any ideas why we have not a get as a member function on a tuple?
To avoid the dot template.
Yeah, the comment is to avoid the template, exactly that. So if you had the tuple which has the get, which like you would follow up other standard containers and things, that would work. Tuple int end, but that wouldn't, because it's the when we have dependent template, we have to put this dot template on it, and obviously that's a lot of dark magic for a lot of people. Auto doesn't work as well because it's still dependent, so we cannot avoid it. So yeah, that's why we have std get for better or worse. I would claim that maybe universal syntax would be able to sort that, but maybe not. I don't know. But that's what we have at the moment. So let's implement a simple tuple, which will, satisfy all requirements for the getting nth element out of it. So that's how we'll, interface with it. It's basically the same interface as tuple has. Any ideas how we can, simply implement the tuple, like with a liner?
Captured in lambda.
Yeah, exactly. We capture in the lambda, and that's the simplest tuple. We can do it better with forwarding arguments, blah blah. But yeah, I would claim that's the easiest tuple to implement, one-liner, and it's perfect for the slides. So how we can do get out of it? Since we have this lambda, we just apply the lambda which for the tuple, and that will give us the args.dat, which are expanded, and then we are in our comfortable position when we can apply the nth pack element with the n argument from the get call. Make sense? So I wanted also to point out that tuple interface is not great. std get is not ideal in my opinion. Get on tuple would be nicer, but we have the template. So what about if we apply it a bit differently, like with this 0_c, which is like constant integer kind of value? That allows us to avoid the dot template, and it kind of mimics the behavior of map and other things. So I would claim we cannot get that. That's okay-ish, but that would be nicer, in my opinion. Tuple of n elements. So how we can do that? We can do that in a slide. So we have a tuple extension, and then we just do operator, index operator with. So this guy here should have a concept for like integral value, and then we can because it can be a number, because number will get an int or something, and that will screw us over. But if we pass the integral constant or something like that, this n will be the integral constant. We'll have the value conversion to n, and we can do called std_get on ourselves. But how we get this 42_c? Well, we have to do a bit of magic for that one. So we can apply this UDL, which is kind of universal with. Pardon?
It's the pow. Power of. I know. I'm sorry.
Yeah. So what we do in here, I notice that that doesn't compile because of this proposal, but it's nice on the slides. So we get the integral constant of an int, and then we get the characters and try to do a toy basically on it. So we have to get the character subscribed from the 48 and do that expansion over all the characters which we have in order to get the number. So 42_c will produce the integral constant of int of 42. And then this thing which is passed here, integral constant is convertible to an int that will get the value there. Are there any questions to that? Who? Yeah?
Where did you get a const bursted power?
Great question. The question is that this function is not const_expr.
Yeah.
That's true. I implemented my own, and for the slides I just put std. Assuming that by the time these people will watch, they'll have that. Yeah, but good point. The power is not const_expr. But if you have implementation like custom function, I would have to explain what it is. So I couldn't be asked. So yeah, any other questions? Who would like that interface for tuple? There are some hands up. That's probably why we don't have it. I personally would like it because, in my opinion, it's more consistent with what we have with other containers, and it avoids the problem with the .template. But there is a bit of magic. So David Stone has this proposal for const_expr parameters that would allow us to pass a value here, because that would be moved into the const_expr template auto value. So then we could apply this tuple of 0, and that would be a const_expr. So that would be nice. But we don't have that either. So how we can implement tuple in Circle? That's notice the blue background. I think that's how you should do that. So you have a tuple. We have TSS that. That's the feature which you are lacking the most, in my opinion. So we have the Variadic pack, which is a start, and no unique address in case we don't have anything. And the get. Voila, tuple on a slide. Obviously, we avoid all these constructor and other things which tuple has, but yeah, in my opinion, that's really expressive, and the approach here is the same. So we would have this value taken from the integral constant to get the nth element out of it. Who would like that? Yeah, but basically everyone would like that. Okay, so the questions?
So in the last slide, the n there is not a simple integral value. It's the
Yes.
UDL.
Yeah.
Okay.
So the question here is that the n, it's still the UDL because otherwise it will be an int. It wouldn't compile. Yes?
No, there's actually a built-in operator to do it.
Yeah.
Sean saying that Circle is even more awesome and it has built I'm not surprised.
That was exactly my question. If you have parameter packs built in like this with square bracket, why do you need tuple at all?
Valid point. Why we need a tuple when we have that? In order to do the benchmarks. So okay, we all were waiting for that. Always measure, because you never know. I had my assumptions. There were bold claims here as well. Which solutions are faster, which are slower. But without measuring, and measuring always is good in the end-to-end environment when you have, micro benchmarking is good, but it's not ideal. That's what we will do here. But in the application use cases might be different. But if you optimize, getting env element, we definitely speed up a lot of things because a lot of things rely on that. So if you compare the readability, yeah, well, not a lot of to say about that. Most solutions are kind of dark magic or requires preprocessor or compiler extensions. Recursion requires a bit of magic too. MP11 is a bit better. And circle approach is what we actually want, I think, in the language. But it's not C++, so for newbies, that would be difficult as well, because what is the syntax? And how we will do the benchmarking, we'll use MetaBench from Luidian. So that's Ruby kind of generating the code for nfpack element with n elements. Like you write this ERB file, and that will generate CVP1, CVP2, and so on. And we'll measure the compilation times of those. Make sense? Okay. So yeah. So let's see GCC. As you see, those two. So here we do it just for 200 elements, but you see the trend that. And notice the numbers, because the numbers will kind of vary between compilers. So it will be interesting to see. But what we see here that the recursive solution number 2, which didn't have the overload, is actually faster, and that will be the same across other compilers. But we see those 3, are really slow, and those 3 are. The recursion, and preprocessor. So if you go to maybe, and that's for GCC 11. So we see that out of things which compiled on GCC, because not all of them compiled, the args expansion, because the constant expansion didn't compile, is the fastest if it comes to 200 elements. And in the beginning, it doesn't really matter. So if you use, tuple for like 10 elements, doesn't matter which solution you have.
Why is concept expansion on this one?
Because GCC doesn't compile it. Yes?
Why doesn't 10 elements matter? That seems like that's actually the case that does matter, because most tuples have 10 elements.
I mean, like from the benchmark perspective, if you looked from the high level perspective, it doesn't matter as much, because if you have 200 elements, it costs us more.
Sure, but if you're compiling 1,000 tuples of 10 elements,
I see.
It seems like the case that would matter for most production use cases.
Yeah, for most, probably.
Doesn't look like they're. Doesn't look like they're. Do you have a log scale?
No, I don't. I don't know whether you can zoom that. Okay, well, let's see how it scales for Clang. So for GCC, that was like 120 something seconds. So we see that the Clang is a bit faster if it comes to compiling the same things. And the fastest solution for the highest number is the concept expansion. So that seems to be the fastest here. And there are a lot of solutions which are recursiveness is really bad. Preprocessor is also not that good, and the rest seems to be kind of consistent. So if you disable those guys, we see that all of them kind of are going the same way. So there's no perfect solution here which scale very well with a lot of elements. Obviously, the point which was made that whichever is fastest below there, it's also important if you have a lot of them. Yes?
What kind of machine did you use to run the benchmarks?
What kind of machine I used for the benchmarks?
Did you use like a server or a desktop? Or
No, I just use desktop, like Intel i7 compiler, computer.
did you control for like the dynamic clock speed control
Did I control dynamic?
Yeah, like did you like the processors can change like.
Oh yeah, I did task set on that one. So the question is whether I allowed the switching between the cores. No, I didn't. You pointed because there is a variation of them.
It's curious.
Yeah. I try not to do anything while compiling, but sometimes it just took forever. So random at night.
Says that you checking your email.
Do averages or are these single data points?
Single data points.
Okay. MetaBench does averages.
Oh yeah, so it's MetaBench, so whatever that is.
The default is average of 3, I think.
Okay, so that's the case. So the command was that is an average of 3. Okay, so let's take a look into circle. So let's notice it was 100. Oh, sorry. So the first thing I noticed is the scale is a bit different. So the recursion took 100 some seconds in GCC and Clang. It's just 28. So already better. All the solutions scale well. But there's one here which is kind of much better than the other ones. So so if we compare, like those guys don't matter. Yeah, it's kind of, we can go further and further.
Wow.
And that's what we get. So
All those emails.
yeah, a few emails in the between, but it didn't really matter because it's less than half a second to get nth element of 200 Variadic pack. So I'd say that's pretty good. And the reason being, I don't know whether I'll do the justice here, but maybe Sean can do. The fact is that the reason why that scale very well is basically linear is the fact that when you have the Variadic pack, the accessing the nth element is just like accessing an array of the base node, and after that the static cast to one of the arguments or something like that. I don't know.
I mean, the back index is constant time. It's just you run the template substitution once on that index.
Right.
So I mean, it's linear time to instantiate the tuple or the lambda, whatever you use, but the subscript is constant.
Right. The comment here from Sean that the subscript of n is constant. That's why we see it basically as a constant.
So in your benchmark, you're just getting the nth element once, or are you getting it n times?
Per n.
Yeah, like so for 200, it's like a tuple of 200 elements. Are you getting all of those elements?
Yes, all of them. So yeah, the question, sorry, that was on the ERB slides. Yeah, we get in all the elements out of 200. So 0, 1, 2, up to 200. And we do that 3 times, and then the average is taken into account. So okay.
Median. We're taking median, not the average.
Median of 3 rounds?
I think median of 3 is the default. I'm looking at the source code right now.
Okay, so the comment here is that MetaBench takes the median of the 3 rounds.
Nope, defaults to 1 now.
Median of 1. So the claim here is that if you do a lot of TMP, up to 20 elements, we've seen that the values were really similar. However, although they differ just a bit, if you have a lot of instantiations of them, that would matter. But if you, on the large scale, if you have a lot of instantiations of more than 100 elements, that actually doesn't matter as much because you will have bigger problems. Recursive solutions do not scale well. I wouldn't use them.
But if you're doing up to like 10 or 20, are they still worse, or are they actually?
Yeah.
Sometimes it just comes like this
right.
from under.
So up to 20, it seems the values are very similar. But yeah, I didn't zoom in as much so that I don't see how much the difference is. But I would argue that yeah, if you have a lot of them, that might not scale, and if you put more, that wouldn't at all. So yeah. So clever solution, they scale a bit better. Obviously, they involve a lot of magic, but they scale pretty well. That's actually not on this one, sorry. Let's ignore that comment about tuple because I will get to that. So I think the claim here is that the approach which we actually want to see is the language feature which just destroys the competition no matter what. It's like doesn't matter which solution we pick, Quasir, not Quasir, MP11, this magic hack or the other one. If you had the feature in the language, that would be constant. Maybe Sean's solution, half a second, whatever, can be even faster, but it doesn't matter because it's constant across n elements. So tuple is actually even more interesting to see because we see the implementations of standard libraries. Obviously, they have a lot of magic involved as well in order to. I would assume the gain was to make them fast, but we'll see. So here the approach is the same. We generate a tuple. We generate a tuple and try to get each element of that tuple. So GCC 11, that will be with standard library. What we see here. So when we apply, recursion is even slower, but the tuple here is the fastest. So good job, GCC, I'd say, because they outperform all the solutions which are provided by the things I tried. But it takes 9 seconds. Let's keep that in mind. So GCC, I think, did the best. Like I don't exactly know what they did as implementation, but it's better than what we have so far here. So yeah, good job. So Clang. So for Clang, that's not the case, unfortunately. So we can improve the lib C++ a bit with, for example, arg expansion and concept expansion, or MP11, type bug element. So tuple seems to be not as well optimized in Clang as much as in lib C++ as much in lib standard C++.
Is this still lib standard C++?
No, that's lib C++. Lib C++, yeah.
Oh.
So yeah, the comment here was whether that was lib standard C++. No, that's lib C++ because we use the Clang. But the main point here is the fact that if you can find a solution which is faster than the standard implementation in lib C++, that's maybe not as good. GCC somehow outperformed all the solutions, although it was slower either way. So that's good from one side. Okay, so let's see circle. So we'll have to zoom in order to get it. But what we can see here is nothing matters beside this one. Because, yeah, it's even faster than the other one. I think I didn't check my emails as much. Yeah, so I think what is worth noticing is the fact that all the solutions seems to be compiling faster than other compilers, so we can do better. I'll take that out of the question. Circle is awesome, but notice the fact that lib C++, which is the backend I tried with the circle, doesn't use the circle features. So if you don't use the circle features, you still get better compilation times, but not as.
What was it on Clang? It's 6.5, is it?
The question is, yeah, let's compare. I don't know. So what was on Clang? See, Clang, tuple, 8 seconds. So I think the point here is that Circle compiles the standard library C++ tuple even faster than Clang on its own, and the tuple in the standard library doesn't use any features of Circle, right? So that's why we have the difference here. So if you applied features from Circle to tuple, like that would be a huge difference. That would be a huge win, in my opinion, for everyone. So some highlights. So recursive, we don't care. That clever solutions are okay. Yeah, circle destroys the competition like by far, right? There's not even a comparison here. But STD tuple is not leveraging that. So although we're gaining, we're not gaining as much as we could if we just use the STD tuple. Some notes regarding that, just to see where the compiler stands between each other. So I use the newest available compilers. So, and compare the best and the worst solution for 200 elements, because that's the use case which I cared the most. So we see that for GCC 11, the arc expansion was the fastest, 6 seconds. For Clang, the concept expansion was the fastest, 4 seconds. And for circle solution was the fastest, which obviously is much faster. And for tuple, like you see that GCC STD tuple is the fastest solution they provide, but we can do better in Clang with concepts. And the circle is just a different league altogether. So yeah, if we can, switch this one into here and here, I think everyone would be happy and have more time on checking emails. What about the worst solution? I think that's also important, is the worst case which we have. So that's why we don't want to use the recursive stuff. Notice that all of them, so recursive, the first solution of the overload for the recursion, it's across all compilers the worst. So there is something there that's slow. But how slow? On GCC is the slowest. And we see here that we could speed it up. Like Circle can, compile the same solution much faster than the GCC can and than the Clang has. So I think we can do better as well. But yeah, altogether, we see that compilers can do better a bit if it comes to the compilation times. Are there any questions to the benchmarks which were provided? Yeah.
So why is 200 elements the one that you cared about most for production? Do you do lots of tuples of 200 elements?
Yeah.
Oh.
So the question is why I cared about 200 elements the most, because that's the use case which we have the most. I see the value in verifying smaller tuples a lot of times, which I didn't do. Sorry about that. But I think the results will be the same.
Okay.
Maybe not across different solutions as much as Circle would destroy all of that.
Okay.
Which is basically the claim of this talk, that if you had the feature support for TSS in the language, the compilation performance would be much better. So if it comes to readability, there's a lot of hidden magic sometimes in all those solutions. So definitely we should hide them behind tests and better interfaces which are not exposed to our users. TMP, don't use the recursion because you might be beaten at some point. And I think everyone will attend the Sean's keynote tomorrow, where all this magic will be even more magical in a sense, but it definitely will scale well. So I can guarantee that. So in my opinion, it's a great addition to the language which we could have and benefit altogether. So lack of that feature, I believe that it's hurting us at the moment because, some of the projects and especially in high frequency trading, you can imagine a lot of and other like embedded stuff where you have a lot of elements. And you would like to be able to compile that, and up to recently we wouldn't even try that, but right now we can. So we try more, and we push the limits. I don't know, to the 1,000. Let's say that's the limit right now where we stand. But maybe you could do 1 million at some point. Imagine use cases for that. So yeah, I would believe that would be awesome to have, and that's really, really nice as we stand. So yeah, let's pack some more language features. Thank you. Are there any questions? Yeah, Zach?
Yeah, so it's not really a question, but just for the record, that exact syntax that Circle does with the square bracket n was suggested before 11 by Doug Greger and rejected by Evolution because they didn't like the syntax.
I see. So, so that's a great comment. So Zach said that the syntax which Circle is using was proposed before C++ 11, and it was rejected because of the syntax.
The reason I'm bringing it up is I think it's crazy, but that's what happened.
Yeah.
You try to backshed the syntax to something better. They like the feature, they just don't like the syntax.
It died because multiple iterations of syntax, none of them could find consensus. Yeah, everybody liked it in principle and wanted the feature, but no one could agree on syntax.
So we like a poison pill. Like, we're going to pass something here. We got to fix something. Right?
I think it's come up.
We need this feature, okay. We're going to backshed until we go home or something.
I think it's come up more recently than that even, and the excuse that was given then is that it'll be part of general metaprogramming, so we can just wait for that.
Right.
General reflection, so we just wait for that.
Yeah, the comment is that we can wait forever, yeah.
Well, yeah, that's roughly the comment.
Other questions? Yeah?
So when you write these at functions, in general, you can favor the small case or the big case, right? You can do the big case very slowly and do the small case very quickly. You can write it in such a way as to do the small case very quickly. So like when I did the at function for which I needed for MD span, right? I assumed that almost all the use cases were going to be 1, 2, 3, or 4 dimensions. And so I made those very, very fast. And then I just used plain recursion for everything after that. Because if you're using a 12-dimensional array, you're kind of going to assume your compilation is going to be a little slower anyway, right?
Right.
And if you're using a 60-dimensional array, then you're just trying to break the compiler.
Yeah.
So, and that's why I brought up the smaller use case. Because I think that that's an interesting aspect of this that would be a great follow-on top.
Yeah.
And it's actually the one that seems to me, at least in most code bases I've worked on, to be the more useful one. Compiling a tuple of 10 a million times instead of compiling a tuple of 200.
A million times.
Yeah.
Yeah, it would be nice to like special case the smaller ones.
Yeah.
And that's exactly what Kvis here does. That's exactly what a number of other implementations do.
Yeah. Great comment. Saying that depending on the use case, compiling smaller number of elements could be, sped up in comparison to the bigger ones. Because obviously everything depends on your use cases. The use case which I try to get here is that we have a lot of tuples which are big. But yeah, there's the other side of that when we have a lot of small tuples, like really a lot of them, which are the main use case.
I suspect that's why libcxx looks bad, because they looked at it and they said almost all of our users are using 3, 4, or 5 elements, and they made those really fast, and then said we don't care about the rest.
Right. So it's a potentially valid comment, yeah.
Are you able to share what you're doing with 200 elements? I was curious.
Like reflection.
No, I mean for work.
Yeah, like reflection. Like basically you have a, protocol which has 200 fields or something.
So like an entity component relationship kind of thing?
Like parsing, for example, and then producing events out of fields and.
Why is it a tuple and not a variant?
It's not actually a tuple either, but yeah, it's more like. How to say it without saying it? Just a parsing. Yeah.
I think I got it. Yeah.
For parsing, it would usually just be variant.
So that's fine. It's the same problem.
Except for
Michael?
variant, you can
I just
do
gotta say,
totally different.
there are lots of places where
Because they're all
you
the same
have
person,
uses
the same
for
person.
tuples of large sizes as you're trying to do more at compile time so that you have better construction and knowledge of your system and compare it.
Right.
Compile time. So Odin's talked a lot about that over the years. I've talked a lot about that over the years. We're doing this stuff with Intel and are getting ready to talk a lot about it. But ironically, you know, at least for us, very, very small systems, we have large, huge amounts of tuples in order to optimize our system at compile time and produce something that's very small. And I'm not surprised that the community likes 10, you know, element tuples because they don't ever like the embedded world.
I'm
So,
sorry.
It's okay, DJ. I know it's not personal.
Yeah, so the comment is there are use cases for it in embedded and others. And I think there are more and more coming because so far we couldn't do that.
Yeah.
Good question. Thank you.
A comment. I found it interesting that the Clang built-in was no faster than the arg extensions.
Yeah.
Strategy.
Yeah, I was surprised by that as well.
It's too bad. Maybe we need some more Clang extensions, more Clang extensions to speed up things.
Yeah, good comment. Yeah, potentially. Yeah. Good question there.
Do you have any advice for the audience that wants to participate in improving on this?
Do I have any advice to audience who want to participate?
Getting started, comparing results, those sorts of things.
Oh, yeah. So if you want to start comparing things, I think the best way to start is just to clone the meta bench from Louis Dion and explore the solutions. I think that's the way to start.
libcxx accepts pull requests.
Yeah. The comment is like, you can add a merge request, change something. Okay, thank you very much.